Right. Differentiation by the first principles. This is just the introduction to calculus, focusing on differentiation. So, without wasting much of your time, let us just dive right into it. Differentiation by the first principles. So what does the first principle state? The first principle states that f prime just says that just differentiation f prime of x. This is just the same as dy dx. dy dx simply stating that this is the change in y with respect to x. The change in y with respect to x. This is the terminology that we use when we are talking about what? Differentiation. So f prime of x, this just says that this is the first derivative of our function x. The function x, f of x, can be any function, can be a polynomial, can be a trigonometry, can be anything. Any function represented by f of x. So we want to find the differentiation by what? Using the first principle. We are going to see that as we are going to be moving forward, there are a lot of things we do. Either we are going to be differentiating by the first principle, or we are going to be differentiating using the rules. We are just going to arrive at the same answer. So this is just different techniques. There are many ways of killing a cat. So let us kill our first cat using the differentiation, using the first principles. So what does the first principle say? That it says that the limit as delta x approaches 0, bracket f bracket of x plus delta x bracket minus f of x bracket over delta x bracket, something like this. This is the first principle. This is the rule, or this is the formula that we are going to be using when we want to differentiate using the what? The first principle. So let us just give one example. What is this formula implying? What is this formula saying? Let us go into the what? So take note of the what? Of the formula. So supposingly, we have got our function, f of x, which is equals to x squared, and x is equals to 2, and x is equals to 2, and then they say that differentiate this function using the first principle, and x is equals to 2. What are we going to do? We are going to write our formula f prime, which is going to be equal to our formula. We are just going to substitute. Our formula was saying that limit of delta x as it approaches 0, bracket, where we were writing f of x plus delta x minus f of x bracket over delta x, something like this. We can see that we have got our function here, and here, according to the first principle, we are supposed to substitute this thing into our function, and in the function we are going to write it as it is. So what are we saying? We are going to take this function here, x squared, and we are going to substitute x plus delta x. So it's going to be x plus delta x bracket squared minus the first principle was saying that f of x here, f of x, we already have f of x minus x squared bracket, something like this, and we are going to simplify here. Limit as delta x approaches 0, bracket, this one is going to be x squared plus 2x delta x plus delta x squared minus x squared over delta x bracket. This one and this one, they are going to cancel each other, and we are going to be left with limit as delta x approaches 0 bracket 2x delta x plus delta x squared over delta x bracket. Something like this. Beautiful stuff. Beautiful stuff. Beautiful stuff. Okay, let us remove this. Let us remove this. Let us remove this. Yes, we are continuing here. We are continuing here. So this one we are going to be left with. This is equal to limit delta x approaches 0 2x delta x bracket over delta x plus delta x squared over delta x. This one is going to cancel with this one. This one is going to cancel with this one, and we are going to be left with limit of delta x as approaches 0 bracket 2x plus delta x. Something like this. Something like this. Bracket. Now we are being told that this delta is approaching 0, so we are going to go into our function and substitute everywhere where we are seeing there is a delta x and put 0. As we can see, we have got only there. Here is only where we have our delta x, so this one is going to be equal to 0. We are going to be left with 2x. F prime of x is going to be 2x. Here we have differentiated this function using the first principle, and we want to see that at the point f is equals to 2, what is going to be our function dy dx? The rate that our function would have changed at x is equals to 2. So we are just going to say f prime of 2 is equals to 2 bracket 2, which is equals to 4. This is our final answer. This is our final answer. Now you tell your teacher, I have substituted, I have differentiated this function you have given me using the first principle.